Hello everyone. Today we are here to discuss a problem of LeetCode. The problem number is 263, the ugly number problem. So first of all, we will see what the question is telling us, and then we will discuss the concepts which we need to solve the question. And after that, we will implement all those concepts during the coding part, and we will solve the question accordingly. So without wasting any time, let's move to the question. So what does the question say? The question says an ugly number is a positive integer which does not have a prime factor other than 2, 3, and 5. So this is basically the definition of ugly number, which you have to check. So what does it say? It says, let's suppose there's a number n. How we will say that this number n is an ugly number? For that, n should be divisible by 2, 3, and 5. Divisible means completely divisible. The remainders should be 0. So if n is divisible by anything whi- which is a prime number, let's suppose I, and is divisible by I, and I is a prime number, is a prime number, then this case is not in the consideration, as the question says, the prime factor other than 2, 3, and 5. So we don't want that number to have any prime factor other than 2, 3, and 5. That means this case will be rejected. Let's say if there is a number 14. If we see what are the prime factors of 14, you will say 2 and 7. So 2 is one of the cases we want, but we don't want 7 because 7 is not listed here. That means it will be rejected. Now, let's say if there is 1, 1 don't have these factors. 1 has only one factor, that is 1. But 1 is not a prime number. So because 1 itself is not a prime number, it is a valid case. For 0, 0 don't have any factors. If 0 don't have any factors, then you can say that, oh, it don't have any factor means it can be true. But no, that's not true because here the question says is a positive integer which does not have a prime factor other than 2, 3, and 5. So according to the question, it should be a positive integer. Generally, positive integers start from +1, but 0 won't be a favorable case. I will show it to you later. We will check it using the LeetCode itself. So after that, there's 2, 0, 1, then 2. 2 have the prime factor 2. 2 is itself prime. It do not have 3 or 5. But what is the question telling us? Read the question other than 2, 3, and 5. So the question is not telling us that it should contain all these three, all of them, or any one of them. So we will consider that 2 will be a favorable case because it contains 2. Same goes for 3. 3 contains itself. So 3 will also be a favorable case. Now let's come to 4. What is the case for 4? It will be 2 into 2. It contains 2. It will also be a favorable case. Same goes for 5, this logic, and for 6, 2 into 3. So it is like this. Now for 7, as I told you, 7 do not contain all these three. Let's say for 7, What are the prime factors of 7? Prime factors of 7 are 1 and 7. So here 1 is there, so we are not checking for 1. We are checking for 2, 3, and 5. None of them is here. So it is not a favorable case. And this is why 14 is also not a favorable case. And the question is telling itself that it should be only positive integers. That means any number n which is less than 0 will not be considered. About 0, 0 don't have any factors. It should have some factors to be an ugly number. It do not have any factors, that's why it is not an ugly number. But if you guys have any confusion that no, according to what we have learned from the question till now, 0 can be a prime number, I'll solve it out. So let's move back to the question. This is the explanation till now, the concept behind ugly numbers. I hope it is clear to you. You can pause the video and understand it. If you have any doubts, the comment section is open for you. Now, given an integer n, return true if n is an ugly number. So we will be given an integer input, which is n, and we have to return a boolean value which is true. True if the ugly number case is valid. So now we will move to the examples. When we input n is equal to 6, the output shall be true. Why? We can see the explanation. What are the prime factors of 6? 2 into 3 equal to 6. Or if you want to elaborate it, the prime factors of, let's just take all the factors of 6. What are the factors of 6? It will be 1, obviously, 2, 3, not 4, not 5, and it will be 6. So these are the factors here. 1 is not prime, so we don't care whether it have a composite number. 6 is also not a prime number, so we don't need to check for it. They are, that's fine. But according to the question, we have to check that the factor should not be any prime number except for these three. So we are only checking for prime number. There's no condition for the composite numbers, so we don't care what composite numbers are the factors of that number. Now you can see 6 is equal to 2 into 3. So it is 6. Then it is an ugly number because it contains 2 and 3, and no, not any other prime number except for 2, 3, and 5. So it is an ugly number. Now moving to the example number 2, n is equal to 1, as I told you before. Output will be true. Why? The explanation says 1 has no prime factors. That means 1 do not have any other prime factor except for 2, 3, and 5. Actually, it don't have any. So when 1 don't have any prime factors, then that means 1 will also not be having any prime factors rather than except for 2, 3, and 5. So that's why 1 will be an ugly number and the output will be true. Now for the third example, n equal to 14. Output is false. Why? 14 is not an ugly number since it includes prime factor 7. As I told you before, 14 equals to 2 into 7. 2 is the desired prime number we want, but 7 is not the desired prime number. So that's why we will not consider it as an ugly number. So now here are the constraints given. So it's a good practice to add constraints. Sometimes it's something which is a hint for you to solve the hidden test cases, sometimes not, but it's a good practice to use the constraints. Now, the doubt we had about 0 being an ugly number or not, let's create a case here for 0. Here I will just put the value of n equal to 0. So now we'll check if 0 is a ugly number or not. So first of all, we have to write some code for it. Let's say return true because we are just checking now. That's why I'm just returning the statement. So now we have 0 here. What shall be the output? Output is true because we have returned true here. But the expected output is false, means 0 is not an ugly number. So that's how you can check what you have to do, what you have to implement if you have any doubts in the question by using the compiler and hit and try method also. Let's say there's something given like here it is given it should be a positive integer. So if you want to like check it, we already know that it should be a positive integer, but just for demonstration, I'm also showing you this. I will take another test case and I will put a negative integer here, and here I will check it. Here I'll run it. Now the test case is returning true because I have returned true here, but the expected output is false. So that's how you can check the question with the compiler too. Now, as I told you before, if there is 2, 3, or 5, it will also be considered. So if you want, I can create a test case for that also. Let's say we have 2 here. Now let's see what is the output for 2. So the test case is passed. The output is true. The expected output is true. So 2, 3, and 5 will be passed. So now let's go to the coding part as we have understood the question clearly. Let me just remove the test cases which we don't want. We want 0 to be there for testing purpose. We don't want the prime numbers. So now let's implement the concepts we have understood in the code and see if it works fine or not. So first of all, it's a good practice to use the constraints in a if block in the topmost line so that if the constraint is not fulfilled, the program will exit itself. So for that, I'll just use an if statement here minus math dot power to 31 is greater than less than equal to n, and n is less than equal to power of 31. So we want this condition to be true for the further code execution. So if this condition is true, then the code will be executed inside the if block. But I mean, like, let's say we want to remove the constraints someday in future, then we have to check where this if block is ending, and then we have to remove it from there and here. It will be a bit complex without any tools. So for that, we, also if we want to comment the constraint, we have to comment it here, and then we have to move down to check where it ends, and then we have to comment the closing bracket also. So to avoid this thing, what we will do, we want this statement, this condition to be true. So we will take this whole condition as false. That means if the condition is true, then the condition will change into false, and then the code block inside this if will be executed, and that means it will not return the code execution. It will not do the code execution further, and it will return the value false. So if the condition is false, it will make it true, and when the condition becomes true inside the if, then it will return false, and the code will end here. The program will exit. So now let's implement the code. We have added the limitations. Now the first thing, the number should be a positive integer. Also, let's say the number n should be a positive integer, is greater than 0. But as I told you before, for 0, as I have demonstrated you here, for 0, the output should be false. So here we can see if the number is negative integer, the output will be false. So for 0 2 it is false, and for negative number also it is false. So what we will do here, we just take n is less than 1 containing 0 and all the negative numbers. If n is a negative integer or 0, then shall return false. Now we all know that from 1 to 6, as I have demonstrated here, from 1 to 6, the numbers are ugly numbers. So it's optional if you want to write it. If n is greater than equal to 1 and n is less than equal to 6, then it will return true. This is optional. If you don't want to write it, you can just skip it. I've just used it to reduce the time complexity. Now we have to check only three factors. So for that, I will be taking an array here of factors. The factors are 2, 3, and 5. Now we have to check if it contains only these prime factors or not. So any co-prime factor, let's suppose 14, if there is a number n and n has a factor, let's say 14. So 14 consists of 2 and 7. Let me show it to you here. Let's say we have 32 as n. So when we have 32, what are the factors? 2, 16, 2, 8, 4, and 2. So as you can see, only prime factor here is 2. Now let's say if I have 34 here, how will 34 work? As you know, we will decrease it, we will make it 70. So now here we have 17. 17 itself is a prime number. So this case is not be under consideration. Let's say if a number x has its factor 34, then 34 can also be written as 2 into 17. That means x will definitely be having the factor 2 and 17. That means x should not be a an ugly number. So here we just need to check if the number contains only these prime factors, because the composite number will be a composition of these three prime numbers only, as I demonstrated you before. So I will just use for each loop because we have only three numbers here. So for digit type factor from factors. Now let's say we will check for the number n is divisible by factor or not. Okay, let's say it is divisible by factor. Like in this case, 34 is divisible by 2. Okay, but it contains 17. So we have to check it again and again till the answer is 1. Like this. In the case of 32, the answer is 1, right? So we have to check till the answer becomes 1. Or let's say for 6, let me show you something more. It is 3, right? So for 3, it becomes 3 and it is 1. So again, we are getting 1 here. Now we have to check if the resultant is 1, but we have to also keep it in mind that the factors shall be among 2, 3, and 5, any composition of these three prime numbers. So that's why I am taking this loop here, while loop, because we don't know how many times we have to multiply which prime number. No? So here in this while loop, it will check if the number is divisible by any of these prime numbers. If yes, then what we will do? We will update the value of the input number. Let's say it is factor. No? Let's say it is divisible by 2. So we will just divide it by 2 and update its value. For example, if we are taking 32, we will just divide it by 2 and the resultant is 16. So we will update the value to 16. Then we will check again for 16. 16 is divisible by 2. Yes, it is. Then we will again update the value. And this is how this while loop will work. Let's say if we have 6. So first we will check for 2. 6 is divisible by 2. So it will work fine. And we will update the value. So what will be the value for it? It will be 3. So now in the while loop, 2 is 3 is not divisible by 2. So this while loop will not work and we will get out of this while loop into the for loop. And inside this for loop, we will check for the next factor, which is 3. So here inside this, 3 is divisible by 3. So we will again enter in the while loop, and then 3 will divide it and update the value and make it 1. Now, 1 is not divisible by 2, 3, 5, or any number. As I told you before, 1 has only a single for factor, which is itself. So now, after we get 1, it will return, or any other number which contains any prime factor other than these three, it will get out of this for loop. So now we have two types of cases here. First, if the number is 1, which is the desired case that we want, or if the number contains a prime number which is not one of these three. So to check it, we have already updated the value of n. So we have to check the value of n. So I will just return the value of n. If it is 1, then this is what we want. Yeah. If it is not 1, then it will return false. So I hope the concept is clear to you and the coding part is also clear to you. This line is optional if you want to reduce the time complexity. So now I'll just run it. So as you can see here, it is accepted in 0 milliseconds. Let's submit it and see if it works. See, it worked fine. Here the runtime is 1 millisecond and the memory usage is 40.95 MB. So the memory usage is like this because we are using array here. When we use any data type, data structure, any primitive one or anything like array or linked list or anything, it takes some memory. So that's why the memory usage is much here. If you are interested to know about more questions, please subscribe the channel and we will solve another question in a new video. And goodbye.